Welcome, fam. Today I'm going to do the virtual lab for the Aldol condensation. So try to pay attention. I'm going to show you as much of the steps. And if there's any jump cuts, it's only because I'm doing literally the same thing and I don't want to waste your time. So first thing to let you know is we are using the chemicals piperonaldehyde. So that's a weird looking compound, but piperonaldehyde or 3,4-methylene dioxybenzaldehyde. That is the benzaldehyde that we will be using for this reaction. We're going to be mixing it with acetophenone, which is essentially a benzyl ketone, and we're going to be combining these guys together with a very strong base. So I'm going to go ahead and start the lab, and I will maybe give you updates on how things are going, describing what I'm doing if it's not. But they need the glassware. Didn't feel like we need to spend the full time viewing this, so I've sped it up at 16 times speed, cleaning off like 4 beakers, a micro spatula, and our conical vial. Here, I'm going to find the tare weight of our conical vial. Yeah. Pretty stable. I'm going to try to add the piperonaldehyde to that. Let's see how much that is. Okay. A couple more times. Some into my file. Okay, almost there. One more. Let's see. Oh, that'll be good enough. Okay, and now there's important capping that. Even if someone's going to use it afterwards, at least put the cap on. I'm going to now try to attempt to micropipette a small amount of acetophenone. So I've set the micropipette to 360 microliters. Pressing the plunger in, suck up. Disposing of my first major problem is it says to use 95% ethanol. I do not have. I think I have absolute ethanol, which is, well, being pretty close. Not quite it. I'm going to be. So what I'm going to do is I'm going to prepare 95% ethanol by mixing 9.5 mils of ethanol with 5.5 mils of water. taking very few chances with this reaction. It looks about 9.5. I'm going to add about a half ml of distilled water. Pour this out, let it mix in a beaker, and then I'm going to get my 95% ethyl alcohol and add it to the original sample. Okay, that looks good. Maybe just a pinch more water. A few drops. Yeah, that's probably good enough. Swirl this around. So it has plenty of a chance to mix. Now I'm going to try to get about 2.4 mils of this. That's 2.4 mils. I'm going to pour this into our conical vial. Next step is to put this in a beaker and stir this until it completely dissolves. If I need to, I will heat it. It looks like it has completely dissolved. It's very fruity. Here is the first major deviation from the book. Now I am going to add 0.12 milliliters of the strong base, set to 120 microliters. Now this is 19 molar sodium hydroxide. In the book, it suggests we take 0.6 mils and dissolve it, 0.6 grams and dissolve it in 1 milliliter to make our solution. But we have a problem there, in that our sodium hydroxide tends to suck up a lot of moisture. And so the actual known concentration is really hard to determine. And so that's why I'm forced to use this more concentrated solution. So 0.6 mils divided in 1 milliliter, 0.6 grams of sodium hydroxide in 1 milliliter is what I should have been using. Instead I'm using 19 molar. Still that sodium hydroxide I would have used 0.12 milliliters, so 120 microliters, but the concentration would have been different. Now I'm to stir this until it completely solidifies. And we do have some solid already forming. I'm going to keep reacting this to stir this for some time to make sure all of it solidifies. So, on the clock, I'm going to stir for probably at least another 3 minutes. I'm going to go ahead and stop it now, but I'm going to keep stirring for at least another couple minutes. But let's hold it up so you can see what it looks like so far. I'm going to add about 2 mils of ice water to help break up the solid. Let's see the ice water. Now I'm going to transfer all this to a beaker with about 3 mils of ice water. Let's see. A little bit more. That's another 1.5 mils just to make sure. Wash this out. Okay, so here's our solid. I'm going to filter this through a Hirsch funnel. Filtration. Wash this with our cold water. To isolate my crude product. After which I'm going to let this air dry for 30 minutes. the sides. Maximum yield here. Mushing it, trying to break it up, trying to make sure it's going to be evenly distributed as I wash this. Almost fully filtered. Do a little bit more. One last wash. One last wash, and then I'll air dry. Funnel's gonna filter this through, and then we'll have our crude product. Okay, I've waited well over 30 minutes, and now I'm gonna try to add my dry Chalcone to this tiered flask. Not everything, but most of it. The flask is already tiered, so yields about as you can see, the weight of the sample is about 0.231 grams. So at this point, I'm going to try to crystallize most of my crude product with hot 95% ethanol. So there's about a little bit, 1.8 mils. Try to dissolve this. Might need some more. Similar. It's about another mil. That's about as much as I really feel safe adding. Let's see if I can get this. Let's see. I'm now going to try to heat this up, fully solubilize this, and then allow it to cool, recrystallizing back out. At about close to 3 mils of hot ethanol, and I'm going to continue to heat the ethanol with hopes of fully dissolving this. Check back with me in a few minutes. After I crystallize and I'm removing most of the solvent, see, wow, pouring off most of the solvent, we have beautiful yellow crystals. Now all I need to do is take the IR of these and the melting point. I'll be done. I'll go ahead and report those in a minute or two. So I now have a clear yellow solution. Now I'm going to let this cool down. Try to allow this to recrystallize. So it might take a little while, so I'm going to leave that. While I'm doing that, I'm probably going to check the melting point of our crude product. I just finished the melting point. I'll spare you the tedium, but the crude product melted about 94 degrees, but the recrystallized product melted at approximately 119 to 121 degrees before it started showing droplets around 119, and it's finally fully melted about 121. So you can see a drastic improvement in purity. Okay, so here's the IR of all materials involved. This first image is of acetophenone. The second image is of piperonaldehyde. This third image is of my crude product. And the fourth one is the purified product. So as we see here, there is a significant change between crude and pure. Now here's all 4 spectra stacked together, the pure, crude, and our 2-star materials on the bottom. So this lab is now done. Purified our crystals, we've taken IR, we've seen, oh, there is a significant removal in the crude. So what I ask you to do is, so you write up some regards with the melting point, we produce the product. What can we say about the recrystallization process? Was this successful or not? How can you prove that? Such as, so when you go to prove that, refer back to both the IR and the melting point. So I ask you to do that, and also answer question 1, where you give a mechanism for the preparation of the appropriate product. So we can't really do much else. That is what I asked you. Now we haven't really gone over this in class yet, so with that in mind, you may have to look up the Aldol condensation reactions and try to look at that. But okay, so that is everything you need. Make sure to correctly identify what has changed and refer to that as you write up your procedure. Evans out.